This podcast is brought to you by PC component retailer and boutique builder Silverknight PCs. Use offer code BrokenSilicon to get 6% off everything on their website. And it is also brought to you by CDKeyOffer.com that gets you great deals on Windows keys and other products. You can find links in the description and the proper offer codes for all of these sponsors, and we'll talk about them later. But for now, let's just get on with the show. Welcome to Broken Silicon, a gaming hardware podcast. I am your host, Tom, and today I am, it's funny, this guest was someone that I had talked to, well, not weeks, for months about coming on, and it was like, oh, we may have an availability this month or this week. Oh, Hardware Unboxed just said he's available this week, so let's see if we can have maybe do you in a month, and then so on and so forth. And eventually, I'd say in the past 3 weeks, it became clear we wanted to have you on in April. And I had this feeling like, this is probably a good time too. It's after most of the releases, new games are coming out. There'll probably be things to discuss. But as luck would have it, or as bad luck would have it, you might even argue, there's been a lot of debates online right now about the requirements to get the best performance, the best graphics out of games without using tons of RAM or requiring a 16-core CPU. And so, as bad or good luck would have it, I think we're having you on at the first time. And before I fully introduce you, though, let me do this little thing here. So, your name's Dave, and I want to thank you for coming on today, especially in a time where I think this is a badly needed discussion. But before we start, there was some back and forth about how anonymous you should be. And I think you got approval from your boss that you could talk almost entirely freely, and of course that you could come on the podcast, but there was still, from what I could tell, a little bit of this, maybe we shouldn't say this, or maybe people shouldn't exactly know that. And I thought, well, let's just use your first name. You can show your face if you want to, and frankly, you'll be about as anonymous as me, but pretty much people don't know who I am anyway, so that should be good enough. And so I just want to make it clear that I guess technically you're an anonymous guest, but you're less anonymous than usual. But you are given the go-ahead to not be anonymous. And so it's just that like one layer of separation just to play it safe that we're doing here. But yeah, thank you for coming on. I mean, what made you reach out to the channel?
I mean, I've been a long-time follower of Moore's Law's dad, and hardware is actually kind of my hobby ever since I got bored when I was 12 years old and I read the hardware part of a gaming magazine. And that's when it all started, and I've been following you for a while, other YouTubers, and I'm very tech savvy, and I'm a game nerd, or a nerd in general. So
you just kind of, discovered the channel maybe months or a year or so after watching. You're like, his email's right there. I can reach out to him, and that's just one day you're just like, hey, why not?
Yeah, sure. And I mean, there's been a lot of discussion about games and some misconceptions, so I thought maybe I could clarify a few things. Not all of them, because there are specialists for every part of the gaming pipeline or creating a product. But since I'm a generalist, I think I have a good overview and hopefully can contribute to some cool discussion.
Yeah, and it's funny because there's probably a good point to say, even though you are anonymous, if anyone did find out where you work, your views are your own, not your company.
Yeah, exactly. Thanks for stating that.
But additionally, I think this is kind of a good disclaimer to put out there that I didn't realize we had to say, but the more and more we do this, I think it's a good idea. Like, your views are also your own from what you've seen and how you do your job. You don't do work the same way someone working on the Decima engine or Frostbite or even another Unreal Engine game might do their work. And it's the same even with people working at Nvidia or AMD. I think some people think, oh, well, this person at AMD, told you the codename Serrano and like how that Zen 5 thing works. Well, why don't they know what the memory system is for like Zen 4C over here? And it's like, well, I mean, they probably worked on that some, but anyone working on anything doesn't know everything they could possibly know, right? But you're a generalist. What got you to working on Unreal Engine 5? I mean, as little or as much as you want to tell me about your past, I am curious, like, kind of what got you into gaming, what you studied, and what made you a UE5 developer.
Yeah, sure. Again, I have to go back a little bit. It was when I was very, very young. My father actually allowed me to play SimCity 2000 on his computer every now and then. Mm-hmm. And eventually I got my own PC and I started playing games, obviously. But also, I was intrigued with the idea to create things of your own. So I tried as a very little child, maybe 7 years old. I opened Word. I just put a lot of X's in there, and then that was my racetrack, and the cursor had to go through everything. And that's how I actually started. Then I got into Excel, completely imaginary worlds, created them. Then I get a bit more serious with Warcraft 3 modding, Dungeon Siege modding, and the biggest step for me was Doom 3 modding, where I've actually released 2 very big mods, and the second mod took 7 years to finish.
Mm-hmm. It always takes longer than you anticipated, right?
Yeah, exactly. But it came out too late, so there weren't many players, but they all kind of seemed to enjoy it. And yeah, then I was studying game design. And there I was also at first using the id Tech4, so the engine of Doom 3, to create some very, very quick projects. But for my bachelor thesis, I was using the Unreal Development Kit back from the days of Unreal Engine 3. And that's when I got hooked, because before with modding, it was easy. You don't have to program a lot. There's just some basic scripting involved. Mm-hmm. But with the UDK, there's the predecessor of Blueprints. So the node-based system Unreal uses where you can program simple things and even advanced things, which is great for designers because everything is right in front of you. You can see what you're getting, and it's not just a bunch of lines of code. So I got intrigued, and once Unreal Engine 4 was released, I dug into it straight away and never stopped. And I even released some tutorials on YouTube, small hint, back then. And yeah, every time I got some free time, I was working with Unreal. I saved up for the Developer Kit 2, for the Oculus Developer Kit 2, the DK2. Mm-hmm. Did a lot of experimentation with VR, made my own projects, released only a few, sadly, because I was never too happy with the result. And long story short, eventually I came up with a job, and then I started with Unreal Engine 4, and just about a year ago we moved to Unreal Engine 5. And that's when I really got into development. So not just some basic blueprints, but also C++ or the framework Unreal uses with C++. And now it's my everyday bread, and I have to do everything because the project we're doing, except for 3D modeling, everything's on me. Mm-hmm. So I have to be a generalist.
In many ways, though, I'd say, I mean, obviously it's this hard work and passion that got you to where you are, but there's some luck in what you're doing now, because if you're doing a little bit of everything right now, I can't think of a better job, to prepare you in your career moving forward and stuff.
The best part is that I can also include design. I'm also doing UI design, UX design, a bit of, not as much as I used to, but game design as well. So it's a broad spectrum, which is awesome. I can do everything, but sometimes the downside is I have to do everything.
Mm-hmm. Yeah. Yeah, it's funny. I think back, I went down more of like an engineering route, and then of course took a complete left turn into not programming or engineering, what I'm doing now. But I do remember, like, I played Age of Empires and Rayman on my dad's computer, and I was so excited when the Rayman editor thing came out. Did you ever mess with that?
Not with that, but with the Age of Empires 2 editor, actually. I tried to recreate Gothic 1 and 2. If you know those games. I tried to create them in Age of Empires in the editor, so yeah, great times.
It seems like that's where a lot of people start, is just like a sandbox that's pre-made for you. Well, actually, here's another dorky thing. Far Cry 2 had a map editor, and I remade a lot of SOCOM maps for Far Cry 2's online just because I liked those online maps from SOCOM, and I was like, I wonder if I can do this. And a couple of them, but people will remember from SOCOM 3 Killing Fields on the. Fortunately, they don't share the maps between different variants, but at least on the PS3 Far Cry 2, if you look up Killing Fields, you'll find I think, very accurate reproduction of that SOCOM map. But, eventually, I never did, but a lot of people get into modding. This leads me to a question here from Clean Sweep. What do you think the state of modding with modern game engines? While I appreciate it when games offer official SDKs, I do find it concerning that they often lock down to one service or another, effectively gatekeeping mod making to those who already have an account with Steam, Epic, GOG, or whatever. I find this increases the barrier to entry, and it's a bit depressing, especially since the communal knowledge for modding is increasingly being centralized in Discords instead of publicly available wikis and forums. Yeah, it's almost like there's like collectives of modders forming in less grassroots. I can kind of see that as well. Or would you disagree? What do you think the state of modding is to this day?
I totally agree. When I was growing up, there was an editor for basically everything. That's how I've gotten into it, because if you looked back then at game engines, there was no entry at all. And just the last couple of years, we saw that Unity, Godot, which is out, Unreal Engine 4 got free, starting with the Unreal Developer Kit. The last couple of years, it was, it could be used. But I'm not sure why developers aren't including it. It could be something about marketing, IP protection.
Well, they can't sell you a hat if you can download it for free.
Yeah, but I think it's a downside, because if you look at Skyrim, the thing that kept Skyrim alive was not the original content. It was what was done with the content, with all the, even just funny mods. That's still being played today. Same as some other games that are modded. So I agree, the state of modding, there's just a handful of actual games shipped with an editor built in. A really professional editor where you have all the options. But what we see now seems to be more like a simplified version of integration. Like create your own levels in Mario World or something, what it was. I don't recall. Or I think for Sackboy, could you create levels for Sackboy, I think?
Oh yeah, for Little Big Planet.
Yeah.
You could make entirely different genres of games than they even intended. So yeah, that's there.
That's there. And that's simple,
but it's still it's still in a box.
It's still in a box, exactly. And you don't have all the options you have with actual engines. But the upside to not having as much mod support as we used to is that game engines, or creating games in general, became more democratized. You can just simply download an engine and start right away. But the barrier to entry is much higher, because all of a sudden you don't have just all the assets you already know and you just place a few boxes and jump around. You have to do almost everything from scratch and figure out does the player move? How can I import a jump? I can download something from a marketplace, but I have to integrate that first. There's so many steps in your head. You have to go first. So a lot of people maybe just start like, okay, sure. Not going to try.
Yeah, I'm a little concerned that's happening. Sorry, I was Googling off to the side. Little Big Planet made me go, and I was like, because I apologize, I have ADHD. I just had to find out sometimes. So when I have an idea, I got to double check it. And I was like, what happened to Dreams? Still nothing, basically, from what I can tell.
I've never heard of anything about it again. Sure. Right.
It came out of it came out in beta in 2020, but as far as I'm seeing, I don't know that it's ever. I think that's it. I think it's still in beta with a low player count. I don't know. So, yeah, that was a weird one where it just seems like a lot of developers, studios, major publishers like Sony or Microsoft, they don't know what to do with user-generated content because they want to make money off of it, but they don't know how to.
Yeah, and they don't also want to publicize their tools so everyone can use their tools.
Mm-hmm. Yeah, well, exactly, because it becomes more and more guarded for competitive reasons. So, you look at something like Dreams, and it's like, I think Sony just gave Media Molecule a blank check a few years into development, realized they have no idea what they're going to do with this game. And then it's just still kind of out there in the ether, never really finished.
Plus, it adds another layer of complexity on top. If you're doing an in-engine editor, you have to program basically everything double. So if you're placing just something in the world in the basic editor from the engine, for instance, you have you don't really have to save anything. It's all stored in the map file, especially in Unreal. So that's it. But if you now play the game, you have to create that object. It has certain properties. You have to fill in those properties. So you need an UI. It needs to communicate to this very actor you've just placed. It needs to be saved in a game with all of its settings, variables, and so on. And that's just the start. So this added layer on top is so complex that it has to work with your previous systems that also may be very complex. So it's just a bunch of garbage eventually if you overdo it, or you have to have a very good management of your project if you want to achieve that.
Yeah, it makes me realize how impressive it is. Some games even allows you to make online maps complete and on console and completely within a box. Like I remember on Far Cry 2, you'd go into the, custom games where everyone was playing the maps they had made. And there'd be like a 1 minute or to 5 minute period where everyone joins the room. And then you just see a bar fill up as everyone downloads that map from that person or something. And then hopefully it works. And then you just have to make, like, depending on the internet, it might take someone much longer than that. But I guess I'm kind of impressed that did work in with 16
Yeah,
players.
it did. Also, if you're just creating a simple map with some geometry, some assets, you don't have to store as much in a save file as if you're doing an entire game in there, because it's simply just a transform that you place them in there somehow with tools, a different player character that has its own logic. And then it simply has to store what is my scale, what is my rotation, what is my location. And that's it. And the rest is within that object. If it's just a static or an actor, that's the only thing it needs to keep track of. And that's why this is much simpler than some very complex systems like Dream wanted to achieve.
Let me get to a question here from QH Freddy. He asks, how do you see Unreal as having evolved over time? I still vividly remember a number of UE3 games that were extremely locked down and, in my opinion, consoleized, for lack of a better word. It was impossible to inject things like MSAA into the renderer, even though that was possible for most other engines from that time period. And it didn't even have anti-aliasing to start with, so that was annoying. But on the other hand, many UE3 games have a lot of big modding scenes, so there seems to be some openness in that sense. Are those kind of features discussed much when designing the engine itself?
Yes. I cannot say too much about game engine development itself, but what I saw is that with the Unreal Developer Kit back then, it was easier to extract assets and to import. And then if you can extract them, sometimes you can just change assets that are already in there. Newer engines of Unreal, or newer versions of Unreal have actually protected packaged files, so you cannot do that anymore. On the other hand, I think I cannot say exactly why, but the commercialization of the engines, hard question. Maybe one reason is that back then you had mostly your shipped game, and that's that. Maybe you had some patches, but that came later. And now it's a lot about monetizing your games. And if people can create content for free, why should people buy your new DLC, your new map pack, your new whatever it is? So maybe there's some financial incentive there as well.
Yeah. The thing is, and I know I'm like probably preaching to the choir here, but it's like, I feel like some games you can get away with that. I'll just put it that way. Like, I think about how some games have gotten like 40 online maps over time and endless weapons or, cosmetic DLCs every week. And it's like, yeah, you can't mod the game, but at least they're actually making stuff for you to buy. Whereas I feel like there's some games, like, I'll just say it, like Battlefield, where they don't allow that much modding right now. But then it's like, and it's not the worst because they are adding more content. There's certainly worse examples out there. But you go, well, if you're not going to allow modding, then why aren't you releasing a map pack every month? Like, I get your argument that you want to do this to make money, but you're not. So it just kind of seems like and it's like, I just think these companies need to put more thought into it. Like, are we actually going to fund all of this content every month? If we're not, why wouldn't we let them mod? If we are, hey, private business and all, but you got to actually make it, or you are shooting yourself in the foot if you're not monetizing it.
Yeah, exactly.
And I don't think enough companies think about that. They just go, oh, we shouldn't do that because it's free. And it's like, the only thing you made was like 2 t-shirts every year. I don't think, Leroy writes him and he says, hi, Tom and guest. I know my question is kind of not in the topics, but I'd like to ask you, guest or Dave, if you already are using AI tools to help speed up game development. I ask that because as a fellow game programmer, although I'm in mobile, I'm kind of overwhelmed by the possibilities AI is about to bring to the table on paper. From IDE plugins to help coding, examples of whole open world levels being generated by AI. Let me say that the amount of time it took me to make a critiqued world in some of the games I made for online. If I could just tell AI to make it, I'd be like, good enough, and then I'll tweak it from there. But getting back to this, he goes, 3D modeling, animation rigging, it seems that AI can help in almost every aspect of game development, even on the creative stuff. How do you guys see the future of AI as a tool for game developing, and how would it improve the games? I think we're going to spend less time doing the boring stuff, focusing more on things that really matters and makes a difference to gamers. Sorry for my bad English. It seemed fine to me. Leroy.
Not a bad English, no. I'm also not a native speaker, so that's totally fine. With the last part, you're absolutely right. For now, AI is being used as tools, not to replace anyone, but just as tools to simplify many workloads. What I've used personally was just some ChatGPT for some formulas when I was programming for converting certain focal lengths to millimeters for cameras. But other than that, I think we're using AI already more than we think. When I'm upscaling something or an older texture in Photoshop, it's using AI to enhance. If for whatever reason I'm doing a trailer for a project, for a simulation project, and I only have so little time, I have to record in 1080p, even though I want it to be at 4K, I'm upscaling it using AI. For Unreal itself, I haven't yet really found anything that would help my workflow. Talking about the IDE you mentioned previously, the IDE mostly, I'm using Rider personally when working with Unreal, has a lot of features built in that don't need any artificial intelligence. If you're declaring a variable and something's off, it just tells you, hey, maybe this should be a constant. So if it's not being edited afterwards, it can be a constant. But other than that, what I've seen is quite interesting, especially for testing, automated testing. There's already something in the works for an AI that learns how to play your game, and then you just iteratively let it run through it. And so you can really imagine it as the dumbest user you can possibly imagine, throwing it at your game, and that's how you test it. And that can be done overnight with a very good machine. You can run it multiple times at once, simultaneously. That's one aspect. Then what I just saw a while ago was Ubisoft is actually introducing a tool to generate background NPC talk to streamline the process. Because for a lot of writers, having to write something that's in the background, spending hours on it, and then maybe 1% of people actually listen to it, can be quite daunting.
I heard the total script for Grand Theft Auto 5 was 50,000 pages.
Yeah, and that's a lot of work. And then you have to use it. You have to hire some actors who then record the sound of it, maybe need several takes. And then you can use voice AI for an actor. You get maybe into a contract with, say, okay, you have another $5,000. Can we use it for some additional NPCs? Sure, why not? That's very interesting for the 3D parts. It's also very interesting. I don't know if any of you guys heard Substance. It used to be called Alchemist. I think it's now Substance Sampler or so, which can use any photograph you take and create a texture of it. Not just a texture, but textures with the albedo channels, all the channels you need for a texture for the PBR workflow, physically based rendering. And then voila, you have your material from a single photograph. It can scan, okay, I have shadows here, so this should be a deeper part of the texture, this should be higher. So there's also already being used. And it's just going to continue from there. And one of the next steps is actually probably the AI of the actual game, like drivatars we've seen in Forza, that also become more of an AI standard, and just instead of just simple, okay, if this happens, then that. If this happens, then that. Maybe random branches of there.
And that AI branching is just a ton of work. Like I remember watching some documentaries about like Killzone 2 and 3 and then Shadowfall. With Killzone 2, they actually showed the decision tree for one unit. And at the time, it was pretty groundbreaking how smart the AI was. And it was just, I guess I should do it here so they can see it on camera. I was like it wasn't just like enemy here, do this, and then like blend it off and like different options, and each option had 100 options. If they didn't have the CPU they had in that console, they could have never made it work. That was a limitation on RAM because they could go up to 32 players, but like I know they went to 24 players on the next game, partially because I don't think they use dedicated servers, but also because are they really going to notice the difference between 24 and 32 people on screen? We can make the AI a little smarter, And then Shadowfall, the AI was dumber, actually, and it got panned a little bit in reviews for having dumber AI, and people are like, why is this? And it's like, we had to move to a new console. We had to reprogram it, and it takes a lot of work.
Yeah.
This game took 4 years to make. That game took 8, and we had the time to make the AI brilliant, and we're sorry. It was something like that.
Yeah.
It's so much work. If you could just have a general purpose AI that knows how to fight with a gun, and then tweak it there if you want them to act differently. I can only imagine.
And that could also be the same AI you've just used for testing, for instance. Other than that, for 3D mesh generation, if you're doing 3D scans, you don't just have to go through it by hand and look where are holes, what do I have to fix, how do I create a certain kind of mesh with a certain kind of poly count. There are things you can do, but they're mostly not very optimal. So you have to sometimes even redo the entire mesh. That could easily be helped with by AI. Also, I think Unreal's also going into that for animation, using AI for animation, for deforming. So if for example, my arm, when I put it together, the skin is actually
like
shrinking
you're lifting
a
a weight right now for people listening.
Exactly.
You're showing your bicep flex.
Yeah.
I think you're just trying to show off your arms, to be honest.
How does the skin react? Because if you try to get everything right, especially with human skin, AI can try to predict that based on certain factors. And that is actually much easier to compute than having to do any kind of collisions on the skin, or you have to use morphs that you have to first create. Mm-hmm. So there's also a good way for AI to take place. And I think I could go on hours on how we can use it, but just so you know, it's already being used right now, and it's just going to go from there, and hopefully it'll help speed up the process of developing a game.
This piece of content is brought to you by Silver Knight PCs. Silver Knight PCs is a disabled, veteran-owned GPU and CPU retailer, PC repair shop, and boutique PC builder that is located in Fayetteville, North Carolina, but they ship globally. So if you're in the area, drop by their location to pick up reasonably priced components to upgrade your PC, and know that all of these components come with up to a 3-year warranty, or contact them online and ask them about anything else you want them to do for you, including building a custom PC designed just for you. They really are on the side of the consumer, and they really do put a lot of effort into making everything they sell the best it can be for their buyers. And I know this from firsthand experience. I got my RTX 4090 Supreme Liquid that I'm using right now through Silver Knight PCs, and I even elected to have them upgrade the thermal paste and thermal pads before sending it. And the thing, well, I can tell you that it just doesn't get hot no matter how much power I let the dang thing use, and I can let it use a lot of power. So whether you're in the Fayetteville, North Carolina area and you want to pop in to buy a graphics card, or you want to custom order something from them online, click the link in the description and use offer code BROKENSILICON to get 6% off all orders. Using this offer code BROKENSILICON helps me a lot, and it helps them. And I am genuinely happy to get their sponsorship, as they really are a business that I can stand by as high quality and of genuine reliability. Go to Silver Knight PCs and use offer code BROKENSILICON today. Chris Rich writes in and he says, one of the fundamentals of computing is automation. I'm not a game developer, but where I work, we use a lot of automated software testing, and it's a very useful tool when done right. However, I see very little discussion of this with regards to game development. I know UE5 has features to help automate testing, but have you used them? Well, the answer is yes. Moving on to the next question, though, from him. How much of a game can realistically be tested using such tools? I'm not suggesting it will ever be a silver bullet, but can this help mitigate dev crunch? And I am curious, like, what can't you test, do you think, in the next 10 years with these evolving tools?
With Unreal, you have to distinguish between blueprints and Unreal's C++ framework. With the C++ framework, you can do your basic testing, unit testing, function testing, and so on. With blueprints, though, it's different. Unreal has what it's called functional testing. And what you do is, for instance, you want to check if, let's say you have a car. It uses a waypoint system, and it has to drive from point A to point B. That's the example. Now, in there, you have some commands like, okay, now I want you here to brake to 30 miles an hour. Now you have to accelerate again. And then what you can do is with the functional testing, you create a starting position. Okay, car, I give you these values. And then a trigger at the end. I need you to be here at exact 15 seconds, no matter what, or maybe plus minus a couple of seconds. And then it simply just runs and then checks if it worked. This can be complicated, like, okay, what's your speed you arrive in? What is your direction? And so on and so forth. So you're using the systems you already have, do something where they do whatever they're supposed to do, and at the end, check. That's the basic functional testing. But for unit testing, so just testing a function you've created, I haven't found a way yet, which is actually a good question because at work we're already talking about this, how to do this in blueprints. So a current solution is that I maybe even have to do something on my own. So my own unit testing, a big function library that just goes through everything, input value. I want that result because I know that is the result when it works. It goes through, check mark, print message, successful. So that's the way. But other than that there isn't as much as there is in I call it regular software development. Because a lot of my colleagues, they're working with Python and they have all the tools available to them. But I think it's still the case for games that due to the complexity and that you never know where the player is exactly and what he can do all the time. And then you have the UI on top of it and maybe multiple players. It just becomes so complicated that it's easier or more efficient and doesn't cost as much money if you hire 2 to 3 people who just try to break the thing. So that's my guess for that.
So yeah, you think, it seems like your opinion is in the next 10 years, I mean, kind of like what Nvidia shows off at GTC with the hockey playing robot. If you remember that demo, like, yeah, we'll do using AI to test games with that kind of just like semi-mindless running around in circles, jumping over, falling on things, stuff to see if a game works. But you're still going to need to have a decent amount of people actually playing the game to make sure it works for the foreseeable future.
For a while, but I mean, if Unreal releases something where you can easily check your blueprints, make unit tests for it, or maybe I just haven't gotten deep enough into it, so I just haven't found the solution. But even the automated testing for Unreal blueprints, if you go online, there's maybe 4 to 5 tutorials on it. So some things in the Unreal Engine aren't as well documented as they could be.
You know, it's interesting too, like, and I don't mean to bring up like the basic map editing I did 20 years ago as I understand I could sound like a poser. Like I'm not that's all I was doing is messing around with maps. But I do remember making some online maps. And at first I would try to craft every little thing. Like I'd make a hill, put trees on it, add rocks. Oh, I'm going to put a building here. There'd always be little things like, oh, I didn't realize I put the building a little too high and you can see under it and, or this and that. And over time, unless there was a specific exact look I was going for, where I'm like, oh, this map has to look like this thing I've seen before, I would, and even sometimes in those examples, I would just use the auto-generate map type option, and it'd be like, jungle, this much tree density, this many rocks. Even back, 2-3 generations ago, online editors had that, would do it for you. And I found that if I just let the auto-generator create a forest for me, if it didn't look perfect, I'd just make it do it again. And I'd be like, you know what? I wanted to make some kind of like island defense map. This doesn't look any worse than I would have made it look.
Yeah.
Now let me place the bunkers and the vehicles and this, and then I can just fine tune gameplay based on how far away the spawn points are. Let me just focus on that. What I wonder making games as we go forward is like the next steps of that is, I imagine you're going to have people just speaking into a mic and going, create French countryside city, too big, too small, perfect. Have a river go through it, and AI will just start massively sculpting it. We'll need way stronger CPUs, but they'll be able to do it, I think, in 10 years.
Yeah.
And my question isn't the senior designers. Their jobs are just going to be easier and more fun.
Yeah.
I think it's the people who work under them, though, that I worry about if they'll have what they'll do. Most of them will probably be able to start doing other things. But I wonder what you think about that, because that's what I worry about with AI. It's not going to replace us, but I do worry if it could replace there's no other way for me to put it, the 20% least essential workers in each team,
That is one way to put it. The other is that actually games could, in theory, ship faster because the same people just do less and they don't need as much time as they used to. And that's actually a good point. I almost forgot about the environmental part for AI. Currently, if you're generating something randomly, you use what is called a seed, which is a semi-random number. On that, everything is generated. That has the benefit that you can always recreate the randomness that you've just created. So you put in a 50, scatter trees around, you put in a 49, it looks totally different, go back to 50, and it's the way it used to be. That's what we use also in Unreal Engine if you're creating your own tools, which I did already. I did my own scatter tree for trees because randomized is much easier, but still you have the guesswork.
Yeah, trees are a nightmare if you don't let it do it for you.
Yeah, and it's still there's the guesswork. So, okay, I put in a 49. Okay, now they're too close to each other there, and so on and so forth. Or this is too close to a road and it doesn't really blend well. And I don't know if you guys seen it or if you've seen it, Tom, the demonstration for Unreal Engine 5 where they drove with the Rivian car through the jungle. And
I don't think so, no.
They showed off their new... it seemed like an in-between tool between randomization and artificial enhancement. So everything was random, but connecting parts to one another. Like you have a tree falling down, it knows exactly, okay, I have to lay down here. So it's seamless. As if before you can only add so much detail before it will look just weird and you have to hand place them. And now you can seamlessly blend between certain randomly generated parts. So you don't have to sit there for hours and trying to stitch together all the different pieces, which can be quite cumbersome. So I think for the foreseeable future, it's going to be a mix of randomness and then AI just trying to make your life easier.
Yeah. And, there'd be a lot. I think then that brings up two new worries. Number one, I worry about if it's that easy for an AI to make a game, well, then you could have a developer pop up where they just put out $1 games on Steam that are randomly generated every day. Having said that, though, I would hope, and I don't know, there's some people that seem to like quantity more than quality, but I would hope all that does is mean that these other developers that are, let's be honest, shipping half-assed sections of their game, you can't do it anymore. If an AI can do it as well as you, then gamers are going to say this is unacceptable. I can get this same experience for $1. Like this is silly. So I would hope that, again, what it does is it means that every area feels handcrafted and again, like the best games on the PS360 era or something where it feels like every hallway and every minute was perfect. But yeah, that game took 10 years to finish. Hopefully we can have games come out in 4 years where they only were focusing on the stuff that distinguishes you from lazy work is really how I'd put it.
Yeah, sure. And if open world, the way it's developing is mostly right now just a checkbox. So that maybe a few designers in there, you have your chest there, you can find it, put a nice house in there, maybe create a story. It can still all be done. Or there are these open world games that just use it as a backdrop. There it could be really awesome. Sitting in the background, you never really even get there. Perfect.
Yeah. All right. Carbon Cry writes in, says, how soon will we see actual deep learning techniques used in video games, be it for NPC AI, either behavior or dialogue, or for complex physics? We've touched on it a little bit. What's your answer?
The physics part is interesting, though. I've seen I'm following a YouTube channel about current state of technology and some papers that are being released, Nvidia included, by the way. And it's not Nvidia, but some other institute trying to train AI to recreate physics simulations.
Okay.
So, for instance, the fluid simulation, it takes a long time to render, not just to calculate, then to render. All the effects you have to add, all the simple, the complex collision, the right friction amount, and so on and so forth. But once it's rendered and it's physically correct, the AI can have a look at it, and then you can give it the same inputs, and it's trying to create the same outputs. And thus far, it's already really interesting. It almost looks like the original. So, and actually, like we see with frame generation or upscaling, this could also add to the repertoire game designers can use in the future to speed up physics simulations.
Okay. I guess, and then when it comes to AI, like the way this will be used is just making boxes to simulate the world to create an AI that eventually can be used general purposely in games. Like that's how it will be used. I guess my question also is, do you think AI in video games will fundamentally be computed differently than it is now, where really you're just parking it to a few CPU cores, and because it's an if-then statement over and over, it's not that much work until you put 100 enemies on screen. But do you think we're going to change fundamentally how the AI is thinking, or do you think it's more so we're going to use machine learning to create smarter if-then statement trees for you? You know, which one is it?
I think at first it's going to be complementary, because if you're training an AI for maybe a shooter, for instance, it could become a nightmare for testing, because balancing an AI instead of a tree where you can simply just say, okay, lose that ability right there. The AI, how do you let them unlearn? Do you load a previous state of them, and then they have to learn something else, and then it branches into different parts? That's a rabbit hole that goes so deep. So I think for the time being, it's more complementary, but I could be totally wrong.
Yeah, and I guess you have to think about, it might become an issue if in some, like, let's say you were using this like general purpose AI to control bosses in Elden Ring. You might not want to do that, because in someone's world, what if the last boss figured out a really cheap way to kill you easily? And then that's just what it did every time, and it wasn't fun anymore.
Even if it's not every time, even if it's just an edge case, it still sucks.
Right. It's like, well, I couldn't have done anything. That's not my fault.
Yeah, exactly. And as a developer, you had 100 testers. It never occurred. But then every 200 people or so, it happens. And all of a sudden, you have a shitstorm on your hand. I mean, it's a bit out of proportion, but
right.
You get the gist. So, yeah, that could be complicated. It could also happen with the other AI, but then you can just simply say, okay, that skill, we're going to maybe decrease the damage, which you could do for AI, but AI is still more of a black box, because there are visualizations of what the AI does and how it tries to predict something, but it's definitely more of a black box than a tree. You can just simply look into, okay, you have this state, the player does that, go here.
And why did it do that? Oh, you can literally see how the physics are mapped. Whereas with the AI, it's like, I don't know why it decided to just start jumping on the roof over and over, but it seemed to think that was the way to win or something.
It can get creative, but then you have to have the training process right. But that's, again, just my point of view of what I've seen thus far.
All right. I'm going to shift gears a little bit here then.
Okay, sure.
Knobhead writes in and he says, hello. For those of us who are less technically gifted, do you think you could explain why devs find VRAM and cache so useful? Do hardware companies collaborate with you guys when deciding what features to add on to their products as well, based on what you are finding useful?
There are several factors that you have to take into consideration for VRAM usage. The first one I bring up, because it's one of the most recent ones, the shift towards scanned assets, so photogrammetry. Whereas before you could create a diffuse texture, so just the color information, and you can just tile it, put it on almost every rock. But for other different meshes, you have just different normal maps, which create the fake experience of it casting shadows, basically. Mm-hmm. And then the rest could also be one texture, and it could be used over and over again. And only this one part of the material, the normal in this example, is changed. Mm-hmm. Now, if you're scanning an entire object, everything,
or a mountain, like even a mountain, Death Stranding,
everything is unique. There is basically no tiling unless you do it after the fact that you shot the pictures of the object.
Which is why it looks so good, because our eyes notice that every rock doesn't look the same, but that means that's a different texture, basically.
Yeah. That part also, we are using way more materials and textures because all the small details we have now, that takes VRAM. Even geometry, even not as much as textures, geometry as well. The increased size in assets from back then, 5,000 polygons was awesome. Now we're talking 500,000 or even a couple of millions with Unreal's Nanite. That also comes to that on top. We also have more textures used in for materials. So the basics right now are the albedo texture, which is just the color information. Okay, this part is green, this part is red. Sure. Then we have the normal map, which can fake depth. But it's not creating any geometry. It's simply just, okay, there's a shadow, draw a shadow. And then many others. The most important are metallic, specular, and roughness, which I hope I don't have to go too much detail into that, but just how reflective a surface is. But then now we also have different things like ambient occlusion baked into the mesh, or we have some so-called fuzzy shaders to make moss on a stone, on a rock, look a bit more fuzzy. And all of these different things, we encode a lot of information into textures. Randomization, we can use something that's generated on the fly, but also we can create our own miscellaneous textures to create even more detail on top of that. So what we, for instance, use for large landscapes, or even a flat wall with a texture that's just tiled a lot of times, we create so-called detail maps. And those are put on top of that, mostly in world space, so they cleanly overlap with everything. And that just gives it a bit more, that it doesn't look as repetitive as you've seen in some very old games where you can see the texture tile way into the distance. So there's another part of texture on top of that. Maybe you want to vary that as well. Okay, now in the second part, all of a sudden you see it doesn't look as great because it's a large landscape. Frick, we need 4K, 8K textures. And that just all adds up. A lot of things we used to fake back then. So for instance, a mesh of a person, it used to be back then one mesh, one texture of the entire body, everything in there. Now you have a model with different parts, the eyes, maybe parts of the ears, maybe clothing you're wearing. Back then it was all baked into one large texture. Now it's multiple elements that all use different textures, that all use materials that use many textures. So it's just an explosion of VRAM usage that we have to take into consideration. And if you want the high fidelity of a clothing that I've seen a lot of games actually brag with, where you can see all the small parts of the fabric, that has a cost.
But see, here's the thing. The consoles know that they have a certain speed SSD, a certain amount of RAM, so they can stream it in and out as needed. Yeah. And that's not always true on PC. And I think a lot of people are going, well, this game is 40 gigabytes. How come you need more than 16? Like, what? Why is half of the game in my VRAM? And it's like, well, it's not. I'm just kind of coming to this conclusion now, realizing it. We're storing 1,000 different rock textures in your SSD. But when we load 1,000 rocks at different angles of lighting, it's actually going to become 100,000 textures, because you now have to pre-bake everywhere. You have to bake the light everywhere else, the shadows everywhere else. And that's why it takes up so much VRAM, because it's that diversity, right? Like,
but that was back then. I mean, nowadays you don't have to bake textures into objects. It's an automated process that is much lower fidelity than anything else, because shadows you can get away with a very low resolution. It's just being blended and blurred.
But that still takes up VRAM. Each of those comments. I know it's not. I'm probably using the wrong terminology, but it's still calculating what it needs to look like. And even though it comes from a base of 1,000 different things, the fact that it's at a bunch of different lighting angles means we actually do need to store this. Tens of thousands of this in VRAM now, right?
But that is actually not as intense as some other parts of the actual pipeline, which is basically really textures, meshes that become increasingly bigger. And
I've noticed that too with geometry, that like there are some games that show you how much VRAM you're going to take up by turning settings from high to ultra. And it used to be the geometry, it was like 5%. But I've noticed some games now, they up VRAM a whole gigabyte if I up the geometry.
Yeah, that's true. Because especially if you want to simulate 3D surfaces for some details, let's say, I'm not talking about Lumen or anything else, but a straight wall, and you want the bricks to go out. You could use some techniques like normal mapping, but then once you look from the side, it's still flat. And so what you could do is just extrude a few pieces here and there, blend it with a texture, perfect. You could use other techniques like parallax occlusion mapping, but that costs a lot of performance. So you could just say, okay, a few more extrusions here and there, and it looks better. So these are just the small tricks you can use, but with current technologies, it's not just a couple of polygons you're adding. You're making a 300,000 polygon mesh out of 100,000 polygon mesh from time to time.
Yeah, and I apologize for getting some of this stuff wrong. I am trying to understand though here, because the point I'm trying to get to, I think I'm finally starting to more understand why this is the case, but I've been talking to developers for years. I think back to when Brian Heemskirk and NX Gamer, and I even think, I had on someone from Sony Santa Monica. I had on another, I don't remember if we got to the subject, but I had someone on from Oblivion as well. You know, I've talked to many developers offline who, of course, don't want to be interviewed on the podcast. 3 years ago, they just all to a man or woman said, things are going to be fine. At first, they're going to use the consoles kind of in a rudimentary way, basically just cranking up settings of last-gen games, but they really can move data like fundamentally more efficiently than the PC. And in a few years, it's going to be hard. And then when they would come on the show, you get reader mails and people would say, oh, so should I go buy a 3950X and a 3090 right now? And we would say, well, if you're going to use it, but by the time you need it, there will be better stuff out. So maybe just wait for the better stuff to be out. And I see so many people right now talking about how things are unoptimized. And I go, well, I don't know. 3 years ago, we said it. In 3 years, this will probably happen. It's happening. So it's been 3 years. 3 years, time flies, And as far as I can tell, and I remember, I think trying to think of what, there's been a few games late last year, but I don't think it's like one data point anymore. We have now it's like every game coming out now has issues with RAM management, right? I don't think this issue is going away.
No, it's just going to get worse. Plus, with the adoption of new generation consoles, it's just going to increase. And textures and meshes are one thing. If you're talking Lumen, it basically creates a very simplified scene of your actual scene, and then uses that for the global illumination. Some really scaled down assets, but still it has to live somewhere. And that goes for ray tracing, the acceleration, the data you have to save there, the structures. Every new feature right now seems to just demand more. And if you want to go back, I don't know, do people want to go back to the old days where myself, as maybe a character, has a 2K by 2K texture? Or do you want eyes at 2K in case you're getting really close? Do you want the hair strands to be visible at all times? So it's like with everything, a trade-off. And even for me, trying to stay below the 8 gigabyte target, we have to do so much work to make it happen. Even if we just get a vehicle imported. Sometimes you have a lot of elements, a lot of textures on there, and you then have to bake everything, but then it's not as detailed as they used to do before. What do we do? Do we just generate depth information for the entire mesh and the rest is tile texturing? And so on and so forth. The optimization process to get back to a lower VRAM just takes so much time that even we just said, okay, screw it, 12 gigabyte minimum. Otherwise, we're just going to spend so much time on optimization.
Mm-hmm. Right. And, I think that's, I sent you some pictures that I plan to put on screen here as well. But I don't remember what there were a couple games last year. This is already popping up as an issue. But, then you have Harry Potter come out and it seems like it wants 12 gigabytes of RAM unless you're in 1080p. And then you have Forspoken and I played it. I don't know that it's really that great of a game, but seems to want about 12 gigabytes or more of RAM. Resident Evil seems to have issues with 8 gigabyte cards above 1440p and hard issues. NX Gamer, link in the description, found eventually the game will just crash,
Yep.
And now The Last of Us coming out on PC, tons of consternation about if it's badly optimized or not. And yeah, I mean, maybe it could be more optimized, but the problem I have is I just see so many people saying, we don't need to pay attention to the Harry Potter. We don't need to pay attention to Forspoken. We don't need to. How many games do we need as an example before we have to pay attention? I agree. The Last of Us looks like it could be more optimized, but this is not an outlier anymore. It seems like a trend. It seems like every game needs more than 8 gigabytes unless you're in 1080p and you're willing to use those settings. Although I would tell people, the low settings of today, not in all cases, certainly not in The Last of Us's case, it seems, but in a lot of cases, is the ultra of a few years ago. And I know, and I actually want to say this, I know individual textures may look worse than some individual textures in previous games a few years ago. But what you don't get is how much diversity of them there are. Like how many blades of grass literally look like different blades of grass. How many rocks aren't the same texture multiple times. And that's why they look worse individually, but everything looks different. And even games I really did actually look at every game before we started talking, even games like Dead Space Remake and Atomic Heart, you can see it's not like it's using 5 gigabytes here. It's they're almost using more than 8 gigabytes and usually are in 4K. So even the games that work on 8 gigabytes seem to be barely fitting it in 8 gigabytes. It seems like 8 gigabyte cards are on borrowed time. It really does.
Yeah. And just as a quick note, developers are actually trying to reduce the footprint of textures. There are a lot of simple ways we try to use, as I said previously, variance maps. For instance, if you have a lot of grass on display, you don't have different textures for every piece of grass. What you're trying to use is a randomized texture, maybe a noise texture, a colorized noise texture that you then blend in with the grass. And let's say 1 inch is a bit reddish tone, the next is a bit greenish tone. And then you overlay this to the actual texture of the grass. And this is very simplified, but that is giving you the variance of the grass. So you don't have to have 4 to 5 textures for each. So we're already trying, or I'm trying, and what I've heard from others, we're trying to get around this, and to a certain degree it works. But there's only so much we can do, and there's only so little time we have.
And so, right, I guess that's where a lot of this comes from. It's I think people say, do you not have enough resources? It's well, you could always have more money. But at a certain point, it's there's just going to be some areas in some games where if you have 8 gigabytes, maybe turn the textures down to low. And I don't know what to say. We've had $300 8 gigabyte cards for quite a long time. Honestly, I think actually since maybe 2015, if you think about when the 390 went on discount from that generation. But just to put a little pin in this, though, Manuel Nascimento writes in, and he says, "Hey, Tom and distinguished guest, we've seen recently many games come out on PC with various stuttering issues, shader compilation issues. What is going on with this? Is it a case of not enough time to give devs resources to solve the issue, not enough Q&A time afforded, engine limitations, too many platforms, or component combinations for PC, pressure from publishers to release the game, all of the above, something else? I'd love some input to just overall describe why this is happening, as it's been a frustrating experience to deal with these issues and tarnish the experience of what would be some pretty awesome games that have released recently.
Yeah, absolutely agree. I can only speak from an Unreal perspective, because I was also looking into the same issue myself with the PSO caching, and why is it starting at the beginning? Why isn't it at my PC at work? But if a colleague tries to start it for the first time, he has the same issues.
Mm-hmm.
And then I actually tried to figure it out, but the documentation on Unreal is really only one page, and the rest either you have to figure out, or I'm just not smart enough to actually read the documentation for it. It's not simple to click a checkbox, pre-compile shaders on begin play, or when you're opening the game. So it's a lot more effort to get around that, because you're working with an Unreal, with an engine, and unless you want to change the source code, it's going to be very tricky. And Unreal is a framework that wants you to do things in the way that Unreal wants you to do them. Mm-hmm. So it's a rabbit hole, and there's, at least for right now, no easy solution for this. If you're using Unreal and you're not a total developer like me as a generalist, it's way over my head. I'm trying to do some other tiny tricks, as in creating a main menu, loading a bunch of assets in the background right there. It stutters like crazy, but then you click on play and they have already been created, the shaders for that. But that is such a low level workaround. So any small studio is probably going to have issues with it. I mean, Unreal is trying to address it, but if it comes to engines that are that complex and that big, it's never an easy thing. If you have your own engine, then I don't know, maybe it's much easier.
Well, that's kind of a question that I want to get to here. Like, how much of this is, because it's probably a bit of both at least, but how much of this is it's a little clumsy because we're transitioning into a new era of more complex games, and how much of this is just an unfortunate, semi-unavoidable thing popping up here where, well, if we run the game on PS5 or Xbox Series X, it knows what it's using. The shaders are pre-compiled. Like,
yeah, exactly.
The more games get more complex, the more latency is a factor in performance, and we just have to do this pre-compilation thing on a PC because there's like 20,000 actual combinations that we could pre-compile for, but it's just different SSD speeds, core counts, core speeds, IPC clock speed. Like, it just doesn't work before we even get into the fact that there's like 100 different graphics cards someone could be using.
There are workarounds, definitely. So Unreal is trying to use an asynchronous solution. So if you're starting the game for the first time and you're playing through and a stutter is supposed to occur, they're just not rendering the element until it's compiled. Which is what also could be done in the future. Maybe you have just a few seconds of shader compilation for the very first level, and the rest is being calculated in the background on a separate thread. But that is really technical stuff, and anyone who's already tried to work with threaded workloads, asynchronous computing, well, hopefully can see the issues there. Or the challenges, not the issues, challenges.
Samantha Vimes writes in and says, how is Unreal Engine 5's direct storage implementation going to impact the need for system RAM and VRAM? Could direct storage help cards like a 3050 that only has 8 gigabytes of RAM remain viable for longer? Well, I want to jump in here and say, well, the 3050 is supposed to be like a sub $300 card, so it was never meant to long-term game above 1080p, so I don't think that's the concern. But, who knows? Maybe it needs that, but I'm sorry. Answer the question, though.
Yeah, sure. The last time I actually heard of it was last year in April, I think. Yeah, but then nothing ever happened since then. So probably Epic Games is working on it. Maybe they aren't. I don't know what this date is actually. But to a certain point, it could help. For instance, in Unreal, there's the texture streaming pool, which says, okay, you have this amount of VRAM available. If it goes over that, it gives you an error, and it starts to stream in textures, but very slowly. So you can see these infamous walls that are just plain nothing, maybe just gray So very low resolution.
Mm-hmm.
That happens if you go over the texture streaming pool. And where was I going with this?
I just want to jump in, though, and say I have a friend who was at GDC and saw a presentation for direct storage. And the guy told me, from what I'm seeing, direct storage, if you're doing what the PS5 can do, which is stream in assets while you're playing, to use DirectX storage means you have to use the graphics card. So they're seeing a 20% hit in performance when you're streaming and rendering the game. And then there will be stuttering with the 20% lower performance. So if you want to remove stuttering, you might need to go to 30 or 40% performance hit because, well, it's doing the work of a graphics card and an entire IO system, right? So like that may just be a thing on PC where they're like, you might need double the teraflops to make up for the fact that you don't have these IO controllers or something.
Yeah, and I remember where I was going with this. It's a bit late. I'm getting a bit tired, sorry. With the example I just made, with that you have these low resolution textures that just seemingly won't load. Mm-hmm. If, of course, they can be streamed then faster, you don't have to use as much video memory as you used to. But it can only help to a certain degree because what's in the scene, it still has to live in memory. Mm-hmm. To be computed. So to a certain degree, it may help. Maybe it's been developed for, but I'm not sure if it's going to be a silver bullet for everything.
Right. And that's kind of what I've gotten the impression on as well. And I want to bring this up here because I put this in the notes. Again, perfect timing. I've had the luck and pleasure of like talking to a few people behind the scenes in the past week. Not sometimes when I talk to sources, it's not always to get a leak and say the specs first. Sometimes I just want to understand kind of what to expect out of companies in the future. So I've talked to people that work at Radeon, and maybe they don't want to tell me what's RDNA 5 specs, but they probably don't even know what it is yet because they probably haven't decided. But they also don't want to give me too many hints for competitive reasons. And same, I talked to someone at Nvidia. And I brought up RTX IO and direct storage to this senior person at Nvidia. And the person tells me, there's a smile and just, it's going to help. It's going to help us load. But we need 32 gigabyte graphics cards. And then back in my mind, I was like, interesting from the company launching 8 gigabyte ones right now. But like this person just openly told me, if we really want to do what the PS5's doing, but of course do it in 4K instead of in 1440p on the console, we probably need 32 gigabyte graphics cards. And then I reached out to Chris Ray, who was a guest on Broken Silicon, used to work at Sony Santa Monica, now works at Infinity Ward. And, so there's nothing insider about this, so I can just say it. Like the guy told me, when I was on your podcast a couple of years ago, I said, I want 32 gigabyte graphics cards. Look around. I think we need them, don't we? And he's a visual effects artist, so he's like, I don't know how much we need for DRAM, right? But we might need at least as much amount. And I reached out to some other people this week before me and you talked, and I feel like I'm sitting here. It's almost like before the 2008 financial crisis, and you have like one person saying, all of you are saying these housing loans are bullshit, but like, why are you still selling them? Like, and that's almost how I feel with VRAM right now. Like every person I ask, even at Nvidia, says DirectX storage isn't going to solve the issue. We're being honest. Consoles can have their own bespoke hardware that does everything it wants to do. On PC, how do you solve it? Brute force. We need 32 gigabyte graphics cards, and we probably need 64 gigabytes of DDR5.
Yeah.
I don't know. Like, I don't know if you want to add on to that, but I just wanted to get that out there today. Like, it blew my mind. Someone from Nvidia and someone at Infinity Ward and someone at AMD just openly face blank said it.
No, at least 16 gigabytes of VRAM, as the consoles could theoretically use, but they use maybe 10 to 12 gigabytes. That's the minimum, even for entry cards, 12 gigabytes, so you can play at 1080p or something. Mm-hmm. That's the least amount of VRAM you should have.
Yeah.
Totally agree.
I wish there was like I guess actually the springboards perfectly into this one question I wanted to ask you then. I ask a lot of people who are either developers at a studio or work on hardware, like, what do you think the next console should be? But I want to go about it the other way. If you were developing a game for PC, not console, and it was going to it'll come out in 2 years. So we'll give you that buffer, of knowing RDNA 4, Blackwell, better stuff will be out. Probably stuff at least 50% better than now. and you wanted to have a crisis moment where people are like, this is the benchmark forever. This isn't an incrementally better looking thing. This is crazy. But of course, you can't cut out all PC gamers. You can't make it just the top 10%. What would you drive for? 12 gigabytes, 16 gigabytes of VRAM, or too bad you're not running the game in 1080p medium? And note, I said 1080p medium, meaning maybe an 8 gigabyte card can run it in low in 1080p. Or would you make 1080p medium require 12, 16? Would you want to make 12 cores or 12 threads, or what would be the minimum of that? What speed SSD? And how fast would you need the fastest core? Zen 3, Alder Lake, Zen 4? What would you be looking for?
Tough question. For VRAM, definitely 16 to 20 gigabytes at least, which when developing something, I don't have to really care too much about what I put into a scene, which could save me some time. So from that perspective,
right, with the work you do,
just nice asset. Okay, it has seven different maps. Sure, who cares? Just put it in the VRAM. I have more than enough. Then also take into consideration that if you can run something at 1440p, it's basically just being upscaled to 4K even in the future. So you have more resources even then. For the CPU, I would go with higher core speeds, personally. But that is just because it's for myself and other generalists, it's not easy to actually utilize many cores in Unreal. So single-threaded performance would be king in that regard. So maybe for a console, 32 gigs of shared memory. I mean, to make it future-proof, 16 cores. And of course, very fast SSD.
But all right, so now I'm going to whittle into exactly what you mean. So the game's coming out. It's the next crisis. It's going to look so good. No one can believe it. All games will be compared to it for the next decade. The minimum you would drive for is probably on PC 8 cores, 16 threads. Like, if you don't have that, too bad. Or would you make the cutoff there and then say, and it needs to be at least Alder Lake and Zen 4 or Raptor Lake? Is it like what?
I mean, efficiency is a bit more important for consoles, so maybe Zen 4, at least 8 cores. I don't know how to utilize the Vcache, the 3D Vcache. So, but that could be enough. But then again, if we're improving something like AI, even just navigation in games is more complex than some people may even think. I've tried that with a couple of vehicles moving around at the same time at around 20. I was going under 30 FPS, and there was nothing else really in the scene. So if it's being utilized properly,
you're moving 20 vehicles around like a crazy amount at once, and
that's just limited by a small part of it. Yeah, because they have to find their way, and this is using pre-baked paths. So Unreal uses a navigation mesh that's been calculated mostly before playing the game in the editor. But even then, they have to find their way around things. And then if you have not just 2D, but 3D space, maybe even, it's going to get more complicated. So there's a lot that can actually utilize the CPU. So to make it fully future-proof, 16 cores, and we have an amazing AI, pathfinding, maybe even some AI physics effects that are being faked by the CPU. So there are a lot of possibilities there.
Right. And I want to put this disclaimer out there for people listening. I'm not having this discussion right now with you to suggest that's going to be the requirement. No, that's not what I'm saying.
Subjective.
What I'm saying is, what do I think you would need to really go for it without caring about if you can sell it to more than like a third the PC market, right? Which is to say, you can always use more, but you don't really see it as likely that you'll need more than 16 gigabytes of VRAM. You don't see it as likely that you'll need more than 16 cores, maybe even 8 or 12 cores if they're super fast. And you don't see it as likely that you'll need more than, I don't know, like 32 gigabytes of DDR. Yeah. So like, if you had that, you're like, I don't know what I would do with the rest of the stuff. This is the minimum. Well, you do know what you do, but you're confident this minimum wouldn't hold you back at all. That's what you're saying.
At least for right now, it wouldn't. Yeah, I can put everything in the memory. I can have fully hardware ray traced global illumination. So not just the Lumen, but I can have global illumination fully, period, nothing else. We can even have path tracing or some very cool hybrid like Metro Exodus did with their ray tracing only game. That was very, very performant back then. And if you just add on top of that and make everything path traced, that's going to blow people's minds, or at least my mind. But also developing would be much easier. I don't have to fake reflections. I don't have to place captures. I don't have to rely on screen space. It's just there. So a lot of the techniques we used to fake, I wouldn't even have to use anymore.
This Easter season, Jessie isn't looking for any colorful eggs hidden by creepy man-sized rabbits. No, she's usually looking for new tennis balls at the park or for where my friend's dog is hiding around the house. Me, myself, well, usually during the spring season, I'd be hunting for the best way to avoid paying monopolistic prices for Microsoft software. Well, that was until I was sponsored by CDKeyOffer.com many years ago. This piece of content is brought to you by CDKeyOffer.com, a long-term sponsor of Moore's Law is Dead for a reason. They've been good to me, they've been good to Dan, and they've been easy to work with, and they keep reliably providing the Moore's Law is Dead community with a product that I think PC gaming just needs. In a world where all of our components seem to keep getting more expensive, I don't think we should also have to be milked by Microsoft as well. So this Easter season, whether you're looking for Steam, EA, Uplay, or PlayStation keys, or Microsoft products as well, go to cdkeyoffer.com and use the offer code BrokenSilicon for 25% off all Microsoft products, and then Die Shrink for 3% off everything else on the website. Support Moore's Law is Dead by supporting cdkeyoffer.com this Easter season. Falto writes in and he asks, once games stop releasing on PS4 and Xbox One, will that mean PC requirements to play the newest games will increase? I ask because I've debated this with people multiple times online, and they simply claim it's always bad optimization as to why an old GPU isn't running game X that is only on the new consoles at the same settings compared to another game that is on the old consoles.
I think we answered that already, but it's not about optimization. Because even now, if you're, of course, you could say, I'm creating a MOBA game and that has to run on everything, then you're optimizing for it. Same goes for VR. You have your limitations, you work around them, but now you don't have to for regular titles anymore, at least not as much as you used to.
I also think there's a big misconception here, because I think you see PC gamers go, oh, well, this game's running fine on a PS4, why can't my 1080 run it above 60 frames or something? And I think people fundamentally don't understand that, like, if the console's running at this, then to run it this much better, yours needs to be better. Like, okay, so this PS4 game's running at 1080p 30 frames per second, and you're complaining, and I'm just throwing this out there, I don't know if this is a game or this is true, but your 1080 is having trouble running at 1440p 60. It's like, all right, well, you're running it double the frame rate and almost double the resolution, and with higher res effects and stuff. Like, yeah, okay, so yeah, it's having trouble getting to 120 hertz. The PS4 is like around a 7870 or something. Like, it has more asynchronous compute units, it has more bandwidth, has less stream processors. I don't want to get into this argument people are going to get into in the comments of, is it exactly that? Yeah, it's pretty close. And so what does that put that at? I mean, yeah, so with a 1080, you're looking at something that's, I don't know, it's got to be at least like 3 or 4 times better. But then if you're complaining about, so yeah, trying to get it to like 1080p 120, but do you have the it's not always going to run it 10 times better. And I think if a PS5 game's running something at 60 frames and you're complaining it's hard to run it at 120, well, the game was designed to run at 60 frames, maxing out an 8-core CPU. So you need an 8-core that's twice as fast in single threading, and you need a GPU that's twice as fast. Just run it at the same resolution, double the frame rate. Now, if you want to go to 4K, it would double it again, at least triple it maybe. And I think a lot of people miss that. But I want to bring this, because that's kind of the question we just answered, though. I want to go back to his original question, though. When they stop making games on PS4 and Xbox One, do you think that's going to make games harder to run on PC because of that, or not? Like, do you think?
Yeah, if you're using the old hardware, sure. Especially when we're talking about ports or multi-platform development. A lot of games develop for consoles first, and that is a very specific hardware you're trying to make your game work with. But the scalability of your game, like with the settings, that can easily become an afterthought. So, okay, we need some lower settings higher. That could be, that's a very extreme example. But creating a game from scratch for consoles first versus for PC first is different. Because in consoles, you have some special hardware acceleration, some special features. You're using your GPU is basically on the chip of the CPU, APU. Yeah, APU. It's also different. And if you want to take full advantage of that, you're optimizing for that. And then, okay, now I have to scale it for PC. Then some have 4 gigs of VRAM, some have 24. It still has to run on 8 gigabytes of RAM, but we're used to at least 4 to 5 on consoles, and we can switch between VRAM usage and RAM usage. And it's two different worlds sometimes.
Yeah, I this question here I'm actually quite curious about. Chris Rich writes in and asks, for a game developer or even engine developer, what are the benefits of having a unified memory system where the CPU and GPU have equal access to all memory? Does it help improve performance? Does it help reduce memory usage? How big of an impact does the split memory pool on the Xbox really have? Longer term, is it going to become inevitable for low-end gaming PCs to be dominated by APUs if they are more efficient and cost-effective solutions?
I mean, one part I've actually seen you talk about before, that the low end may actually become APUs. So, yeah, that may happen. But on the other end, I don't know technically too much about that. The only thing I'm pretty sure is
the
that
unified memory thing.
Yeah, the latency will improve because even physically, they're connected with a shorter distance. So instead of now going through the PCI traces from the CPU to the GPU, loading things in memory and everything, it takes a while just because of the distance. And so the latency will improve, definitely. And with that, maybe part of the performance, if you can stream in things faster or have direct access to things. But I think there are people more qualified than me to answer this properly, to be honest.
Well, all right. Let me try to tie up this conversation a little bit, though, with this question. Kinahoon25 writes in and asks, hey, Tom and Dave, I don't know how to feel about 8 gigabyte VRAM cards at this point. Part of me says that 8 gigabytes should be enough for 1080p, but games coming out that even at 1080p, the VRAM buffer is getting close to 8 gigabytes or over it makes me wonder if we're just going over the cliff right now. Do you think getting an RX 6800 16 gigabyte right now for $450 is better than getting soon, presumably, a $350 7600 XT 8 gigabyte in the future? If they were the same performance, one used less energy, but wanted double the RAM, right? The 6800 may have worse ray tracing, but it will do better in higher resolutions, I think. And anyways, thanks for what you do. And before you answer that, I do want to jump in here. And I think you see a lot of hot takes on some websites where they're like, well, whatever this game's doing, 8 gigabytes should be enough for 1080p. And I would go, so interesting for you to dictate what should be enough. Well, you're not making any games. These armchair, but that's starting to annoy me how many people go, this should be enough. Well, the developers decide what's enough, but anyways, go. How would you answer his specific question, though?
I mean, one part I actually just thought about today was, even if you now have the most gorgeous looking games, they're all upscaling from a lower resolution. So if you're talking 1080p native, a lot of high-end games are using 1080p upscale to 4K to barely hit 60.
Right.
So 1080 is really a thing anymore, probably, in that regard. But that 1080p does have to have 8 gigabytes because while a high resolution is important, it increases VRAM usage. There's still the textures and all the assets that have to be loaded in. So you then have to find a way to scale between resolution and texture quality, texture size.
Mm-hmm.
These are two separate things that you have to account for in the first place. So that's why you still have these settings, resolution versus, so you can go up with resolution, but downscale the textures maybe. It's just never black and white.
I do believe that's something NVIDIA is working on. At least something about like tensor accelerated memory compression. From what I'm hearing, NVIDIA is trying to work on a way to compress textures, maybe using tensor cores or something bespoke in the Lovelace hardware, that they're still trying to get that working. But at the same time, I go, yeah, I mean, I guess they're probably doing that because they have to. And again, if they were to do that, that uses up resources the GPU could be using to render. That it wouldn't have to if it had more RAM.
Yeah.
I think Kinnahun, yeah, I mean, look, if they were even close to the same price, I would get the 6800 over the 7600 XT.
Absolutely.
Because it's the same. I mean, at best case scenario, it's the same performance. One has more RAM. The other one's probably going to be better anyways. And if that 6800 even gets close to $400 soon, which it might because of how old it is, I think I just get that over waiting for the 7600 XT as well. But I will say this, I think there's something, I don't know if I'll have a video out by now on this, but there's something weird going on with the 4070. And I think NVIDIA is going to try to find a way to say it has multiple prices that it really doesn't have, which is so unlike NVIDIA. They've never done that before with their Founders Editions, having a one price that's really making all the other ones more than they say the starting price is, right? That couldn't possibly happen again, right, everybody? And I think when I see that, though, I have to wonder if NVIDIA is looking at all of these releases, making the 4070 Ti, losing ray tracing to a 7900 XT because it doesn't have enough RAM. And I can't help but wonder if NVIDIA is sitting here going, oh, we might want to reevaluate what we do with the rest of this lineup already. And then I also think about Ampere, and I might leak this soon too, like some of the backstory on how they decided the segmentation. I do think Ampere was supposed to have 16 gigabytes on a version of the 3080 at first, but something happened that made it make more sense to maybe use a different die because of cost. But I'll get to that in another video. And at the end of the day, a lot of these recent cards we've seen released for mid-range that have 8 gigabytes or 10 gigabytes, they're there for specific reasons, and they didn't have to have that small amount of memory. And NVIDIA was selling us 8 gigabyte high-end cards since 2016. So 8 gigabytes has been around for a while. It's been a long time. And I just wonder if NVIDIA and AMD right now, before they release the rest of the lineup, are double guessing if they should go with 8 gigabytes for some of these cards. Because if they're not, I'm going to say it, they're stupid. If NVIDIA launches a 4060 Ti 8 gigabyte for $450, I mean, good luck. That's the same price as a 6800 now. It's not going to run half the games that come out in a year above 1080p. It's not. I've talked to enough developers. It won't. So I can't help but wonder if, I know Navi 32 can go up to 16 gigabytes. I think the plan was to make 7800 XT 16 gigabytes, 7700 XT 12 gigabytes, 7600 XT, which we just mentioned, 8 gigabytes. I wonder if AMD may reevaluate this and go, oh, never mind, 16, 16, 16. Because if they go below that, it might be an issue. I don't know. I wonder what you think, though. Do you think this is a big enough issue in the next couple of years that these companies really need to double think if they're going to launch an 8 gigabyte card above $300?
I mean, from a consumer perspective, I hope they finally wake up and give us more VRAM. But Hardware Unboxed actually made a nice argument that currently it's planned, or it might be planned obsolescence. So you buy something expensive now, it's pretty quick, but then eventually you just have to upgrade because you don't have enough VRAM, even though the card's pretty capable. And especially NVIDIA still with their marketing, ray tracing, we are the best. But if you can't store the data in video memory, it doesn't really make much sense.
Yeah, and I just wonder, should AMD launch Navi 33 as an 8 gigabyte 7600 XT for $350, or should they call it the 7700 XT, push it as hard as possible, and give it 16 gigabytes for $400? Because the argument would be, well, we're charging less than the 6700 XT and giving it more RAM. Same performance as last gen, but now it's cheaper with more RAM. I wonder if I bet AMD's thinking about that right now, if we should just reevaluate what we call what and give things more RAM, because it'd be a very easy layup on Nvidia too, and I have to wonder if Nvidia is really wondering if they should even bother launching the 4060 in the current state it's in. But I don't know, in the Fermi era, in GCN 1.0, there were double gigabyte versions of a lot of cards back then. I also wonder if these companies may start doing that again at the low end. I don't know, but it seems like we both agree that they should at least be thinking about it.
And for developers, give me a 48 gigabyte 4090.
Yeah, I know. I mean, they could, but I think they don't want to until they feel like they have to.
Yeah.
And now they're probably being pushed faster than they thought they would. So, all right, I'm actually going to skip ahead here because we've been going a while and I know it's late where you are. I do want to get into ray tracing though, because I know you wanted to talk about ray tracing. And from where I'm sitting, ray tracing isn't always a gimmick now, but I have to say always. Because it does seem like a gimmick in half of the games. And when me and Dan talk about it, we both, like we were talking about this earlier this week offline, we can't help but feel though that I still think we're 5 years away from ray tracing being required for almost any AAA game. There will probably be one in a couple of years, don't get me wrong, but I can't help but think that they're just not ready to do it yet on a big AAA game. And it might actually be a decade before it's actually standard. And then I think about I forgot which recent guest said this, but I wonder if they're just going to wait for the PS6, because if the PlayStation 6 and the next Xbox can do ray tracing very well, then at least a developer would know if the game requires ray tracing. They could probably use all those settings and make it launch on PS5. And they could probably at least make sure they can sell it to console gamers, even if half of PC gamers don't have ray tracing capabilities. But do you disagree? Do you think ray tracing is going to be standard sooner? And where do you see this going for gaming?
I mean, currently we're definitely not at the place where it could even become the standard.
Mm-hmm.
But for the time being, it's going to be complementary. Okay, hey, you see these cool reflections? That's a good part. But right now, you're totally right. It's maybe not a gimmick, but it's just it maybe increases atmosphere. It looks better. It's your visual candy on top of everything else. Yeah, but sooner or later, it may actually become the standard. But
do you think
it's gonna be a while?
2033? Do you think 2028, 2026, 2040? I'm curious,
Yes.
Definitely by 2040 it'll be the standard.
No, all of them. Somewhere in between. No, I think the next couple of years, maybe really with the new consoles. But then again, right now, why we have these lackluster implementations is sometimes there isn't enough knowledge, or in Unreal, you just toggle on an effect and then that's it. Mm-hmm. But even for ray tracing, you have to optimize a lot of the materials have to be optimized. Then what you see in some games is the roughness fall off. So if you have a puddle and then it gradually goes from totally metallic and reflective to not, there's a cutoff. It's basically just the value from reflectivity 1 to 0.
Yeah.
And then in between, you can say, okay, at 0.5, I still want it to be reflective.
Mm-hmm.
These are some of the optimizations you have to make. Then how far are the line traces have to go? Forth, back, how many traces can I have? Now it's in shadow, but if I have 2 traces, it's not in shadow anymore because it's some complex lighting behind me. So this is right now, you have to optimize for both regular 3D graphics, rasterization, and ray tracing. So, which is why the Metro Exodus example is so great. They only have to go for one thing and one thing only, and that's ray tracing all the way. So once we have that step, that it's easily, okay, global illumination, check, reflections, check, then it could become the standard because instead of this in-between and optimizing for both, and then, okay, now it's just a buzzword, so we have RTX ray tracing in there, it actually becomes something that you work on full-time, and
and it doesn't help, right, that most of these games are rasterization first, and then they add ray tracing. Right?
Second thought.
That makes it even more inefficient.
Yeah.
So would you say then, not right now, probably not next gen of graphics, but you think once the PlayStation 6 is out, it's going to be the standard, and we're going to start moving away.
Maybe even the 7, because Unreal Engine right now shows that there can be a great mix between software and hardware, ray tracing with the Lumen system. So they're using both. The global illumination is basically a trickery of a very simplified scene around you that's then software traced against. But once you're using hardware, then you have it's higher, it costs more performance, but you have complex meshes that's being traced against. You can have all of a sudden movable objects you can trace against. So there could be some form of a hybrid approach for quite a while, where it starts to blend into the other, but some trickery will still, even with the PlayStation 6, be necessary.
Yeah, so you think ray tracing will be in basically every game, but it's always going to be hybrid next gen. This gen, we're kind of even learning how to use it. Next gen, we'll use it effectively. PS7, we've been using it for 20 years. That's it.
Yeah.
Cut off time.
Maybe next generation, it's used for gameplay in some regard. And after that, I mean, also hopefully, because I want ray tracing. I'm sorry, guys. I want ray tracing. So maybe then we have full ray traced everything.
And I guess that's a question I also have. Is it just because of the hardware and what we're used to, and the hardware we still need it to work on, that that rasterization seems just more efficient to do some things? Because this is something I think about all the time. Like, okay, for like shadows in a jungle, I mean, it's just so much easier if you just use ray tracing to predict where all the rays should go. I get that right now. Or for shadows in Call of Duty, they were doing that. It looks great and actually wasn't that taxing. Okay, shadows, God ray stuff, all of that makes sense to me. But isn't there like just calculating onto the texture where the shadow should go? Isn't that always going to be less hardware intensive than ray tracing? Or do you think eventually it won't be? Ray tracing will actually use less resources? Because I can't help but think that maybe for the next 20 years, a lot of the biggest games that manage to squeeze out the best visuals on a certain, graphics card, there's still that benefit if you have a 1,000 person dev team to pre-bake some stuff. Well, not pre-bake, but you know what I mean. Like, do it the old-fashioned way because it just uses less hardware. Or is that only because our current hardware is built that way? Will that fundamentally have changed, do you think, in 10, 15 years?
Pre-baking? There's nothing I can say about that that's too positive. I hate pre-baking because there's a lot of tweaking in there. The light maps have to be perfect, and some needs a high resolution for that. It's a hassle. So just turning things on and it works is perfect. On the other hand, is right now with the rasterization, it works great. I mean, we've been using it for I don't know how many years, but quite a while now. It's efficient, it's fast. But the more we want to simulate things from the real world, the more we have to fake. And then it eventually gets bloated. This is why we have so many different effects, like start with screen space, reflections, ambient occlusion, even screen space, global illumination. And that all goes on top of each other. So it's just more and more on top of that. So eventually that could become the bottleneck because we cannot just add any more. Plus, with the rasterizer, you only have what's in front of you that's being calculated. Everything else doesn't exist. So all this information is not there, which is why we use all these screen space effects, which can be broken easily if you just look at a certain angle or so. But if you're using ray tracing, now all the information, or at least at a certain radius around you, is available to you. And then all these effects don't have to use any fakery because you can use the actual ray traces for everything. And that's then called path tracing, where really you don't have to have this effect of ray tracing of this. Everything is ray traced. You have all the information around you and nothing like, okay, now I have to do the calculations from the bottom of the screen, but how do I fade to a different one? Now I need to fall back to a baked solution of that, and so on and so forth. So there could become a point when it's just getting too complex to fake everything in just what you see in front of you, that it could become more viable to have all the information at hand and just have one pipeline for everything.
It sounds like you're kind of saying, like, yes, if you had a 100,000 person dev team not using ray tracing and just doing everything manually, will use less resources, but it is getting exponentially harder to keep up doing that, and eventually we're just going to have to use ray tracing for half of it. Yeah.
Even if it's just at a certain point, we see the limitations, and that's why we use the reflections and everything.
Mm-hmm.
Because where do you get the information from if it's not even in memory behind you if you cannot access it?
What do you think there's going to be like, because we're kind of having this awkward period with like SSDs, storage, and VRAM right now. Do you think in 10 years we'll have this awkward period where it's like, okay, technically the game doesn't need ray tracing to run, but we're using it for half of the effects now, and we're not having a fallback. So you can play the game on a 5700 XT, which by the time this happens, that card will be 10 years old. So who cares, honestly, guys? But let's say they'll go, there's no ambient occlusion. There's none of this. Like you just turn off half of the effects, but it can run the game. You think that will happen? Or do you think, will there be more and more games like that? Or do you think it will just kind of be, they just won't let them play it anyways?
Well, at a certain point in time, you have to make the decision to exclude older hardware. We've seen this before plenty of times. Even if it's just like switching from DirectX 9 to DirectX 11, eventually every game, DirectX 11 was the standard, so older cards wouldn't work. Now for DirectX 12. So it's going to shift eventually.
Mm-hmm. And it's basically just happened with DirectX 12. Like,
yeah,
a couple years ago, I could run Strange Brigade in DirectX 12 on a GTX 580. And let me tell you guys, it actually ran it on paper better than I expected, but it was constant stuttering, and I feel like you're saying it took 10 years. Yeah. So if ray tracing was here, it sounds like, you think we'll be like, it'll require ray tracing to play the game, but we'll still be using hybrid.
Yeah.
In 10 years.
Maybe
but
not in 10 years. It depends on how stubborn Nvidia is.
Mm-hmm.
And if there's really enough competition for them to actually push each other.
Mm-hmm. What do you mean how stubborn Nvidia is with regarding to what?
I mean, if we still have maybe 12 gigabytes of VRAM in 5 years,
oh yeah,
then it's going to be hard to have everything or a lot of things ray traced.
It's funny. I complain about like AMD following catch up in features in the past 5 years because they used to, they had Eyefinity. They did like a lot of stuff with HDR first, Tress Effects, Mantle. Like they did a lot of early stuff. And now it just seems like they're not copying, but like follow the leader here a little bit. And it's annoying to me.
Yeah.
They have more money now. So I'm like, what's the excuse, guys? But this would be a thing they could do in the short term, I think, to really push things. Like if they just decided right now, actually, instead of going 24, 20, 16, 12, 8, let's go 24, 20, 16, 16, 16, 8. Like if they actually did that, which they can afford to this year, they could, Nvidia would never make that mistake again, I'm guessing. Or they wouldn't for 4 years until they decided they can get away with it again. Because they were giving us lots of VRAM since Polaris, and then something happened with Ampere where they're like, we don't care anymore.
Yeah.
All right, let me move on to some final reader mails here from ray tracing to a couple other things. Dead Eyes writes in and says, hi, Tom and Dave. In the example of Lumen we have seen so far, software Lumen seems to be hardware agnostic and cheaper to run at the expense of quality when compared to hardware Lumen. It seems to me that using dedicated accelerators should inherently make something cheaper to run, right? So why is hardware Lumen so much more taxing? If it's just because of the extra fidelity, why haven't we seen a potato setting for hardware Lumen that allows for a software Lumen level of quality, right? That's an interesting question. Like if it's harder to run, why can't we just turn it down and it looks better? With a comparatively smaller performance hit, it feels wasteful to have these RT cores on my graphics card doing nothing because I did just decide to switch to software ray tracing because it just performed better. Thanks, and glad I finally joined the Moore's Law is Dead Patreon.
Well, I think I've touched on that before a little bit. It's because they work a bit differently. The software Lumen does use a simplified version of the world around it. For instance, mesh distance fields, which is a simple representation of all the assets around you. That's with Unreal Engine 4 was, I think, pre-built for everything. So it doesn't support moving objects, only static objects. And I think in Unreal Engine 5, it's still the case for the most part. But then they also have surface caching, which is that includes the actual color information, but very, very simplified. And if you're enabling software Lumen, it's just using this very simple geometry around you only for a couple of, I think, 200 meters or so.
Mm-hmm.
and then uses that to gather the information and then to use the software ray tracing. But everything beyond a certain point is still screen space. At least as far as I understand from the documentation, everything. But once you're using hardware ray tracing, it doesn't have to use the extremely simplified geometry anymore in information, because you can actually trace against polygonal objects. So really the entire meshes, you can still use some LODs. So some lower resolution parts, which we use in settings all the time, or less traces. But then you're trying to figure out the result on more information, using all of a sudden way higher resolution meshes. And you can also now support more in general, actually. So if you have a moving car, all of a sudden it's in there. If you have leaves that go through the wind, you have that as well. So it's basically a lot higher resolution.
So you're saying, like, no matter how much you turned it down, hardware is just doing so much more work.
It is,
And if you turned it down to try to have this easier to run than software option, it won't look like it's doing, because it still has to do everything. It won't look like it's doing as much, actually, even though computationally it's actually still doing more than software.
It's still trying to trace against complex geometry, and depending on the implementation, even the surface itself, it now takes into consideration if it wants to do a second bounce. Okay, this is reflective as well, so I have to go around that. So there's just so much more information. Even if you lower the settings, it still has to check.
Let me see here. Let me skip to this one. Envious writes in and says, "Hi, Tom and Dave. How does Lumen take full advantage of ray tracing hardware? UE5 has its own TSR rival to DLSS 2 and FSR2 as well. Do you have plans to build a homegrown frame generation technique to rival DLSS 3 and FSR3? Well, you don't work at Epic. He might have thought you worked at Epic or something.
Yeah. I wish I could. I do have some ideas, but it's way out of my scope. And so far, we don't have too many moving objects or at high speeds. TSR is perfect for us to use right now.
I mean, just your opinion, how do you think TSR compares to DLSS and FSR 2.0?
To make it short, it's fine.
You see them all like just kind of working pretty well in different scenarios. It's not like you don't see like FSR being way better than TSR or vice versa.
I mean, it's still, if depending on the game, it's still DLSS is first, then FSR, then TSR. But considering that TSR is fairly new, and even from 5.0 to 5.1, they just upped the quality quite a bit. It does have potential, and if you're doing some more relaxed games, simulations, you won't even notice the difference. So it scales very well, but for shooters, when we saw it in the Matrix demo, there you could see that it was temporal.
Yeah.
I mean, literally see it was temporal with the small artifacts and the streaks here and there. But a lot of the issues have been resolved, and it's fine. Like, a bit worse than FSR 2.2. 2.2 is the news, I think.
But yeah, you would, of course, enhancements are coming, but you'd still rank it in that order.
Yeah, in that order, and somewhere in between there's XESS.
Let me see here. Okay, Frederick Gunther writes in and says, "What are your experiences with regards to driver quality from developer standpoint with AMD, Intel, and respectively Nvidia? Like, is there? I don't even really know how to ask this question super in depth, but like, when you're working on stuff for AMD and Nvidia hardware, like, is one person's drivers for developing the game better?"
I mean, for us, it was Nvidia from the start. We didn't even
for your systems you use to develop.
Yeah, we're using, I mean, that I can disclose is 3080 mobile, which we're using.
Oh, so the 16 gigabyte?
Yeah, obviously, yeah.
That's just funny because you say 3080 and I'm waiting, and it's like the 16 gigabyte laptop version.
Yeah,
so
the mobile version, which was awesome to have 16 gigabytes back then. And the drivers are fine. I mean, I especially use the studio driver from Nvidia. It hasn't crashed yet. there's no reason to actually go AMD right now, because we're also using other tools like DaVinci, which still scales a bit better with Nvidia, and they're, especially with the 30 series, their hardware encoding. So I can't say too much about AMD, I'm sorry, because for us, right at the start, there was no discussion, Nvidia.
Right. And I think a lot of people like miss, for a team like you or something, like say you have a team of even 100 or 1,000 people, buying, $1,000, $1,000 or $3,000 laptops. That's a lot of money, but is it worth going to $2,000 laptops if you think there's any chance there's going to be an issue? Not even that it's AMD's fault, but I think a lot of the times it's just what you guys are used to, even, right?
Yeah, but
it's not to say AMD is bad. It's just to say it's kind of the standard.
I mean, even privately, I was thinking about maybe getting an AMD card, but then again, that's just so much where AMD with their feature set is still in the lead. And that's why I actually opted even at work for Nvidia.
Okay, let me see here. Brad Medlin writes in and he says, I've done some compiling in UE5 before and seen firsthand how much better AMD processors are. It's somewhat mind-boggling for me how much better they are. Do you see any other use cases where UE5 prefers certain hardware over another? So I have no idea. I've never done this, so I don't know if one works better in your experience or not. But have you found the same? It's kind of worded in a way where...
The question is, what compiling does it mean? There's the C++ compilation, there's shader compilation that you use very often. You can compile the navigation mesh. So there's different things you can actually compile in Unreal. But I think basically for all of them, ever since 4.26, it was getting very well with CPU cores. So maybe that's the reason why 16-core Ryzen works so well. But
I guess, let me throw this question here. I kind of skipped over some of the CPU questions. I'm curious very briefly if you have any input on, like, what do you think E-cores have a future in upping gaming performance? Because it's interesting. If you would have asked me 3 years ago when Alder Lake leaks were coming out, I would have said, oh, they probably won't use them well right away, but eventually they can probably use them just as more threads. But testing at Hardware Unboxed, they're like, yes and no. The problem is when you have a game, an application, unless it's doing highly parallelized rendering or something, that you mostly want to use E-cores for other tasks or only parallelized tasks, because the latency penalty communicating between the big and small cores just doesn't really work for games. Do you think that's going to change? Or do you think it'll only change if they're literally doing something else in the game only on the E-cores and not touching the big cores?
I think that's actually something that has to come from Microsoft, because if you're developing for multi-threaded applications, or if you're using Unreal for multi-threaded, or as a multi-threaded, or creating multi-threaded workloads, especially for calculations, it's not like you're assigning directly a 1-core 4 and execute this code on core 4, and now this is just a basic AI for an NPC, so just give it an E-core. What you're doing is you're giving it to the Windows scheduler. I'm only in C++ for a couple of months or more than a year now. And everything I talked to there, I was before like that as well. Like, can I give a special core a certain task? No, you give that to the scheduler. And the scheduler decides how to arrange everything and does it, and then eventually returns a value. So if the scheduler you're sending your data to makes perfect use of E-cores, it's going to be more performant. Sure. But as a developer yourself, at least not that I know, if you don't have all the total control of what's executing or what thread lands in what core and so on and so forth.
At least on PC.
But that's... limited knowledge I have there, so that's all I can say.
It kind of seems like you're suggesting, like, maybe, but we don't see any examples in benchmarks now where the latency penalty isn't worse than just keeping it on the big cores. So we should be able to prove it in benchmarks if we think it's going to happen. And so far we can't,
If Windows decides, okay, this is easy, I can send it to an E-core, it's asynchronous, so it can wait a while until I get the return value. Sure, then it could be perfect, and the fast cores are used for something that has to be maybe drawn every frame or something. But that's so much optimization in there. I don't know how to handle that even myself. But I guess for that, a real full-time programmer who's doing a lot of multi-threading should be asked.
Yoda King writes in and he says, "Hey, Tom and guest, I've noticed how many developers, mostly AAA, have chosen to adopt the Unreal Engine 5 for their next games. Is there any reason we should be worried that this will cause a lot of games to feel samey? Much like how many games using the Source engine sort of all just started to look the same, and a lot of Unreal Engine 3 games all look the same. Is this something people should be concerned about for Unreal Engine 5?
The closer we get to photorealistic environments, I don't think so.
That's what I was thinking as well. Is it's like, isn't everyone just trying to look real? I mean, maybe you'll notice similar bugs in loading a game or something, but once you're playing, you're just trying to make it look real, right?
Yeah, I mean, that the most important part for Unreal games to look similar is actually the lighting itself and the shaders. And while most games nowadays, or even all engines, use the physically based rendering, the PBR system, how the information is interpreted into a shader can differ, so that you have the special kind of look to something. But as we just said, everyone's striving for photorealism, and everything else that's stylized, you create your own materials, and you can go nuts with the effects. Some outlines for comic style, and they will look different from anything else. So wouldn't worry too much about that in the long run.
I don't think so either. I can't see. And if I'm being honest, like a lot of Decima engine games, like from Horizon to Death Stranding, kind of look similar, but I only think they look similar because I think the facial animations and eyes look so realistic. And I'm like, oh, it's a Decima game because the eyes look good. I don't think it's because like the eyes look the same to me,
Yeah.
Zane Muket writes in and says, "Hi, Tom and guest. Recently, the Godot game engine got a big update, and it seems to be catching up to the larger engines. Have you looked into the update? What are your thoughts on Godot overall? Also, is it a large advantage for a game engine to be free and open source? Does it really not make a difference to a developer? They should be able to get the engine anyways."
It does make a huge difference what engine you choose. The reason why I, in the first place, opted for Unreal Engine was blueprints. Because I'm a designer first. I've had to learn how to develop. And having blueprints in front of you where you can actually see the logic, like begin play, which is a small node. Then you draw a line, delay 5 seconds. Okay, I know this will wait for 5 seconds. Another line to another node, execute whatever. Maybe let the light blink. That was easy for me to understand. That's why I went to Unreal. Plus, they have a lot of tools already implemented. So you don't have to use any third-party stuff. But even if you do, the marketplace is huge. You can buy everything you could ever dream of almost. And just the insane tool set you have at your disposal is awesome. I mean, I can do everything in Unreal except for maybe 3D modeling, but even that's supported now. So I don't even have to use a 3D program. Maybe in the future not at all anymore. But that's speculation. So it's just this entire tool set. You could compare it to the Adobe suite maybe. All in one, and other engines, they like this feature. All of a sudden, VFX, okay, they're totally different. You don't have your own particle systems. You have to go somewhere else. And Unreal is just this package with everything included, and that's why it's, I think, so popular, plus the marketplace. But of course, if you're having a very simple game, Unreal can be overwhelming because you have to learn like 4 to 5 tools. I'm working with 4 to 5 Unreal tools every day. And even for me, it's sometimes hard to keep track of something. Switching to developing for a day, then going back to materials. So that's why I think it can be overwhelming. So for smaller games, maybe the Godot engine is not too bad, but
it's because it's simpler, right? It's not because it's open source, or like how much does open source really play into that?
If the community is big, it could blow up, but I can't.
But it's really because the community is big.
Yeah, I mean, Unreal has
really what it is.
Yeah, but also Unreal has a huge community right now. I mean, if you have a question, just go to the forums, and there's depending on how complex the question is, a high percentage it gets answered just because of the fact there are so many people working with Unreal.
Mm-hmm. Let me see. All right. I think this can be the final question then. King Harkinian writes in and says, what are the upcoming technologies that you think are going to involve gaming? Lumen basically allows fully dynamic lights and shadows. Nanite is a sort of super evolved auto LOD. What's next in line to advance games in graphics or physics?
I mean, I hope global illumination, real time, always.
Mm-hmm.
No exception. Physics as well could be the next step. I mean, we're seeing with the Unreal Chaos physics engine, which is quite performant actually, and it's looking amazing. It could be used for particles. Perfect.
It still seems there's a lot of games that like skimp on the physics.
Yeah, but it's like hard to calculate. It's especially if you look at games and then there's sometimes frame drops. Mm-hmm. Most of the time, it's either particles or physics. That's a lot of times the bottleneck for things, because what's also very hard for games to run is collision.
Mm-hmm. I feel like that's something that's going to be improved just drastically, though, because I still feel like we're still trying to get everything running in 4K, and then have enough VRAM for textures, and then have enough CPU cores for AI. And then, you turn up the physics and it drops to 20 frames a second, and they're like, whoa. I feel like we're getting there, though. Like,
yeah,
we're getting to the limits. Like Bannerlord, you can have 1,000 people on screen. You have most people saying they don't need to go above 4K. I do think physics is probably going to be like, there's games with great physics, but there's always limitations. That's probably one of the next big things.
The physics and even nowadays, if you're creating a mesh for a game, and even if it's a very complex statue, you usually just create a very simple version of it, like 100 triangles maximum, and that's the actual collision, because it's so much easier for everything else. So collision, physics,
global illumination. What about view distance? You think, because I'm so tired of, there's still so many games where in the distance it looks like a PS2 game, like, and it looks so bad, like in the distance. Some games they don't, but when I think of games that look great in the distance, like Death Stranding, it's like, well, they don't need to render that much in the distance besides the landscape. So that's why
the advent, especially of Lumen, which was actually quite true. It is just a different way of an LOD system that is virtualized and is actually making its own LODs during runtime. Mm-hmm. So that makes it much easier to draw things in the distance, because it's working on a per pixel basis. So downside, the higher the resolution, the more you have to calculate. But still, if you have 1 pixel and there are 100 triangles in there, it's asking itself, easily explained, why do I have to draw 100 polygons? Just make one out of them. So pixel based. And with the advent of that, you don't have to manually create LODs. Okay, now I'm very close. Can I get away with 10 yards away from me? And now it looks still the same if I tweak a few values and then just go all the way.
Then I walk 10 feet and all of a sudden the skyscraper turns into looking like a cardboard box.
Yeah.
You think that'll go away soon then, basically?
If other engines also support or create a similar feature with basically an auto LOD system that not just creates LODs and then switches between them, but actually blends between them gradually. Yeah, it's at least to some degree, it's going to go away.
I certainly hope so. But, I'm sure none of that will depend on VRAM, right? We'll be fine with 8 gigabytes no matter what with these.
Obviously, sure.
Nvidia says it's enough. It has to be true.
Yeah. They wouldn't lie to us, would they?
All right. Well, that's all the questions that I wanted to get to. Do you have anything else you wanted to bring up or discuss, though, before I let you go? I know it's really late where you are in Europe.
Yeah, a bit tired, but the only thing that I actually saw somewhere else was the alternative to FSR.
Yeah, please.
What could it be? And I think some people have already heard of it. It's called, let me check. asynchronous time warp or asynchronous reprojection that's being used for VR already. For instance, the PlayStation VR 2 for Gran Turismo 7, they're calculating everything and it's just 60 FPS. But they're upscaling it to 120 and it still looks great. Because the in-between frames, they're actually using the movement of the camera to then use what's on screen, rotating it or slightly moving it until the next frame is generated. And maybe that technique could be used for FSR 3, 4, DLSS in the future. Instead
to
of
make the interpolated frames much higher quality.
Exactly. If you're moving very fast, of course, you could see something on the border of the screen, but you can easily get around that just by calculating a bit more that's out of the screen. If you're using a basic rasterizer, but that could be a good approach. But the downside of asynchronous time warp or reprojection is with objects that are very close to you, and if you're then moving your head. So especially for third-person games, it could become an issue. Maybe that's why you only see it in...
That was a big issue with DLSS 3 in Flight Simulator. Like anytime you switched to third-person or really just moved around the plane in third-person, there were tons of artifacts.
And that's basically just the parallax effect you have even in real life. If you see some skyscrapers in the distance, they barely move, but if something's in front of you. So occlusion issues as well. So what do we use? So the question is, can you actually apply VR asynchronous time warp to frame interpolation methods? And I think that could be very interesting.
Well, yeah, and I don't know if this is a dumb question or thing to bring up, but I brought up to developers foveated rendering, which seems to just be allowing the PlayStation 5 to run PSVR 2 games at significantly higher perceived image quality than they really have any right to run at on that console. And when I ask, well, what about putting a couple cameras on the, monitor, watching where your head goes? And I've been told you kind of can, but it's because you're not just tracking your eyes, you're tracking your head at different distances and lighting. The thing with that foveated rendering in the PlayStation VR 2 is there's two cameras right next to your frickin' eyes with the exact same lighting every time, basically.
Yeah.
It's super easy to track that. It's really hard to track me doing this while I move my eye around with different lighting levels and light sources all over me. And while it's conceivable on monitors, every dev's like, that's like a decade away. Like, that's really hard to calculate.
I guess that's something for AI to figure out where you are. Same with if you're using cameras and they have eye detection, they're getting pretty smart. So it could be possible, but you're right, the lighting...
Does that affect, though, what you said, though, with the asynchronous time warp, though? Is it maybe going to be harder to do in FSR or DLSS in a similar way? Because, are they using that to track any of it or not? Because if they don't, I wonder, why doesn't DLSS already take this into account?
They are actually just using the data of where your head is in space.
Right.
So they're reprojecting based on where the headset is and the change of movement. So if you're rotating a third-person camera, if the information of where you're looking at one frame later, where they have to figure out where should we reproject it, that's being used to rotate the
But it has nothing to do with the headset, though. That's my question.
No, the eye tracking is something different.
Right, and they're not taking that into account for that either. They just happen to have made it work really well.
Yeah, it's been, I think, even with the first release version of the Oculus, the consumer version, they had that even then. So,
but I guess that's my question. Why have these VR devices been adding in free frames for years, and DLSS 3 has this issue? Because that's why I said this might be a dumb question, because I thought it probably was unrelated. But I'm just wondering, well, if it works so well there, why isn't it working well here? I wonder.
That is a very good question, and there's even a good video of Linus Tech Tips where he's testing it even with 15 frames per second, 30 frames per second. It's not a magic bullet because the lower the actual frame rate, the more you can actually see that something's happening and something's warping. But it's still better than having to render the first frame, nothing, third frame, and then combine the two to one frame before that. Which introduces latency, is what we see with DLSS 3.
Mm-hmm.
So I'm still wondering why not, but maybe it's an occlusion issue, or maybe it doesn't work for every game perfectly well. It's hard to say.
Yeah, because I just found it weird because it's like, well, the PlayStation VR 1 had some version of this too. And I've used it a little bit, like, where it went from 60 to 120 frames and, seemed to work fine without artifacts. So I'm like, is that because I have a dedicated box? Is it the dedicated box and it's just hard to make the card do it? I don't know, but like, that's what I'm wondering.
Yeah, me too sometimes, but maybe that's, more complicated than we could ever imagine.
Yeah.
Or they just haven't figured it out.
Go easy on us in the comments. If I send
if we're saying stupid, yeah, sure. But even when I was researching it, I couldn't find anything why it's not being used in frame generation.
Yeah. Okay. Well, that was interesting though. But if that is all though, I do want to thank you for coming on. I suppose you're staying pseudo anonymous, so people know you're Dave. People know you work on Unreal Engine 5. I'm doubting there's anything you need to plug then.
Not really. I mean, remember, I'm a generalist, so I have knowledge of everything, but not that much in detail. So if there's anyone saying, "Hey, yeah, but you forgot about that or that," I'm sorry. But I think the scope is important, especially for everyone listening, that those are the issues that even I'm dealing with every day, with the performance optimization, with the VRAM trade-offs, making trade-offs. Maybe here this is faster, but then I have to take into consideration math that's being done in the background. There's just so much. Yeah, so it's complex. It's never just a simple answer for any of these questions.
Yeah. Again, like I always say, I'm not an expert on anything, so go easy on me, guys. I'm just trying to make us all understand more about this. With me, I'm trying to understand as well at the same time as most of the viewers. But yeah, all right. So thank you so much for coming on. Thank you so much for giving us so much of your time, and thank you to everyone for listening. Subscribe to Moore's Law is Dead. Ring the bell button. Subscribe to Broken Silicon on a podcast app and give us a review. If you want to get podcasts like this early and ad free, even the video versions, we're now doing that as well on the Patreon. So support us on Patreon. You also get ad free videos of Die Shrink that only patrons get as well. And thank you to everybody who watches. Thanks to everyone who supports us, and have a good week, everybody. This podcast was brought to you by the YouTube channel and website Moore's Law is Dead. Moore's Law is Dead and Broken Silicon are trademarks of their creator, Tom. That guy is me, and I am indeed the creator, editor, writer, and showrunner of Moore's Law is Dead podcasts, videos, articles, and other media. However, it's not just me. Moore's Law is Dead is a team, with Broken Silicon co-hosted by my brother Dan, audio editing by Gerard Cortez, renders being done by the industrial designer Jean-Philippe Clermont, and special assistance is also provided by Carbon Cry and Kerry no Sugata as well. Find all of our information at www.mooreslawsdead.com on the about/support page. In the event you do want to hire me for consulting work, hire Gerard for audio work, hire Jean-Philippe for industrial design work, or you're interested in working with Carbon Cry or Kerry no Sugata as well. You can also find our long-term sponsors on that page if you want to show them some love for putting food on our tables. Or you can also mail us some love. You can send letters or hardware donations to the following address: Moore's Law is Dead, P.O. Box 60632 in Nashville, Tennessee, zip code 37206. Although, to be honest, the best way to show Moore's Law is Dead some love is to support us on Patreon. Patrons are what makes Moore's Law is Dead content truly possible. Every month, and really every day, depending on who you're talking about, me, Gerard, Dan, and Jean-Philippe are working tirelessly to provide a steady stream of content that we could not keep doing unless we knew the work was possible without being reliant on sponsors dictating every little thing we put out. Don't get us wrong. We love our sponsors, but we love directly working for you, our fans, much more. If you have any extra money, even a couple free dollars a month, consider supporting us directly on Patreon. Those couple of monthly dollars will get you access to the exclusive podcast Die Shrink, voting on subjects of future podcast episodes, the ability to ask guests questions, and of course, access to the Moore's Law is Dead Discord full of like-minded people who I am sure would love to meet you. I am one of them. Additionally, higher tiers get access to early, ad-free episodes of Broken Silicon, the ability to ask questions in all Broken Silicon episodes and Loose Ends live streams ahead of the recording, and the entire back catalog of Moore's Law is Dead podcasts, in addition to having thanks in the credits of videos and podcasts depending on the tier, with other perks available as well. And hey, if you cannot afford to support us directly every month, please do share Moore's Law is Dead videos and podcasts with friends and family, and on social media and websites like Reddit, and give Broken Silicon a 5-star review on Apple Podcasts or your preferred podcast app of choice. All of this does really help us so much. But like I said, this podcast would not be possible without the patrons directly providing predictable and reliable support every month. And so now it is time to give a personal thanks to the greatest of the fans. The following supporters are at the 10 gigahertz or higher supported levels: Brad Medlin, Drita Full, AV, Anthony Greffa, Greg Pataki, Mohammed Akwari, Brett Jones, Aaron Close, Little Germany, Jan Rauner, Daniel Hyde, Shredbird, Brian Riggleman, Dr. Forbin, Sam Miller, Deke, Josh Law, The Mechanical Philosopher, Joe Foot, SNES Chalmers, Tom Bailey, Greg T. Wanchik, Andrew S., Frank Zielinski, Daniel D., MJB1, Eric Jackson, Just Christopher Croson, Joshua L. Herrera, Valko Malev, the Boss Haas, Nicholas Buckner, Phantom G. Spamton, Jonathan, Lord Starstream, General Trips, Blake, Franco Frederic, Matthew Lazier, Jensen Wang, Nathan Mose, Alex Vega, Gregory S. Acker, Dominique Koch, Jake Dude 23, Jake Martin, Cameron, Fenty CZ, Hard4Room.com, Original Ross, Slicky, Lance Bassler, David Cowden, Ricky Tan, Christopher A. Butler, GZ Ziggy, Sarcastro, Stefan Hart, David Sebastian, Meat and Pork, Stu, Tim Robb, Luis Correa, Ian Clifford, Jesse Jaskowiak, Travis Gooding, Holden Mobley, Nanyan, Chris Rich, Steepest Learners, Mad, Zutsu Taylor, Stephen Coates, Michael McGee, Chuck Glidden, Sammy Malas, Greg, AWS Danny, Patrick Rowe, Amiable Chief, Brett Summers, Milton, Stephen Dick, Tommy, John, Brucia, Mark Mitchell, Mac Daffy, AC, James Anderson, Marshall Pierce, Mark Raidmaker, Dave Schultz, 3DS Boy 08, Halbuma, Joseph A. Madrigal, Matthew Landabazo, Stefan, Koadik, Jenry Zhang, Judson N., Keith Moore, The Grid, Michelle Pell, D31337 Antics, Joseph Kelly, Earth Torres, Hexapuma, Byzantine, Jerome Ferreira, RB Racer, Keith Moore, Michael Cozy, Ben, DNA Tech, Toka, John O'Shea, Royce Meyer, Charles Russell, Reginald Ari, Slushbot, Tika Autumn, Jackson Miller, JSMMH, Neith Razink, Mean Dean, Richard Yao, Andre Jacques, Gaiman, Since Reagan, Jeff Sedler, Jordan Simkovic, Loophole 35, Winstar, William Welpe, James I. Rader, Corey Leonard, Nelima, John Shin, Justin Bustle, John Swin, Austin Hagerty, Roger Davies, Shay, Julian Leaked, Corey Chappelle, Evan Dingle, T2, John Iverson, Michael Aaron, The Eternal Dreamers, Jansen Angima, Him Sagun, Derek Lambing, James Mosher, Kiko Sato, and of course, thank you to Sahara for the music, and thank you to Jesse for just barely not being a complete idiot while I tried to record these credits. Bye-bye.